Okay, so we are going to do the June 2013 M1 paper, starting at question 1. Okay, so we've got this little scenario here. We've got the 4 blocks. Okay, so the bottom one's the easiest one. The top one's the easiest one to do. It's got its weight down, 4 and so 4G must be up because 4G is down. Then the next one, well, it's got 4G down from this one. That's touching it. It's got its own weight, which is 5G. Therefore, up, it must have 9G. So the forces on this one, well, there's the contact, so it must have 9G down. It's got its own weight, 7G, but it's staying still. So the reaction up must be 16G. So let's just make that really clear to the examiner that we know the forces acting on the 7 kg block is 7G down, 16G up, and 9G down at that point. There we go, that's question 1. Okay. Question 2. In this question, air resistance should be neglected. Okay, golf ball is fired. Horizontal, vertical components of 15 and horizontal component of 20. 15 in the 15 in the horizontal direction and 20 in the vertical direction. Find the initial speed. So speed is not a vector. So the initial speed is the Pythagoras of that. 15 squared plus 20 squared, square rooted, which gives you 25. The reasoning for that is we've got kind of 15 in this direction, got 20 in this direction. So our speed, our scalar is in that direction. Okay, find the range and the flight time. So I will go for kind of s equals ut plus half at squared. And do it in the horizontal direction. So x equals ut and y equals ut. No acceleration in the x direction, but there is in the y direction. Says take g as, doesn't say, so we assume 9.8, a half times 9.8 t squared. Okay, and we want when it lands, so when y equals 0, so we've got 0 equals 20t minus 4.9 t squared. So we can divide through by t, because t is 0 is not the solution that we're after. We get t is 20 over 4.9, which is 4.0816. I'm going to keep that in my calculator. And then the range, so my x at that t equals 15 times 4. So I'm going to keep that in my calculator. Times 15 is 61.22 meters. 61.2 meters is probably, can't really quote it more accurately than that. Okay. Then it says part 3, show that the range is the same if the initial velocity of the ball are 20 meters in the horizontal and 15 in the vertical. Okay, so we're going to do exactly the same thing, but this time x equals 20t and y equals 15t minus a half times 9.8 t squared. So t equals 0 equals 15t minus 4.9 t squared. T is different this time, 15 over 4.9. So x equals 20 times 15 over 4.9, which is exactly the same. 2 meters. Interesting. So that's part A. So we've sent it off a different speed, but we've got the same answer. Part B then asks, okay, is this true whenever the ball is hit with the same speed? And the answer is very simply no, it's not. There are some where it's the same, but not all of them. It depends on the angle. For example, 45 will give the maximum. If the angle is 90 degrees, then the range will be 0. Or you could calculate any other value. That's the easiest one because I don't need to do anything with that one. Okay, but to get the mark you do need to state an example, okay, of it not working. Question 3. Okay, so this is our vectors question, so let's be careful to keep things in vectors. Okay, which of P, Q and R has the greatest magnitude? So the magnitude of P is the square root of minus 1 squared plus minus 1 squared plus 5 squared, which is 20 to the square root of 27. Magnitude of Q is the square root minus 1 squared plus minus 4 squared plus 2 squared, 16, 20, 21. And the square root of the R is the square root of 2 squared plus 5 squared plus 0 squared is 25 plus is the square root of 29. Therefore, R has the greatest magnitude. You do actually need to state your answer. It's not just enough to work them out, but we don't need to work them out as decimals. Third form is fine because we're just comparing them. Okay, part 2. So a mass 0.4 has these four forces and its weight acting on it. So force equals mass times acceleration. Let's keep it in vectors. So it has these forces, minus 1, 5, plus minus 1, -4, 2, plus 2, 5, 0, plus its weight. Well, we know its mass is 0.4, so its weight is 0.4 times, and we've got vertically upwards, so it's vertically downwards, so it's 0, 0, minus, and g is 10, so 10. Okay, You don't actually use marks if you use 9.8, but it just makes your numbers a bit nicer. Equals the mass, which is 0.4, times the acceleration, which we want as a vector. Okay, we add all those bits up, and we get 0, 0, 7, minus 4 is 3, equals 0.4a. So a equals vector 0, 0, 3 divided by 0.4, which is 7.5. And then it says, find the magnitude of the particle's acceleration and describe the direction. So once you've got it in vector form, and they do really want you to have it in vector form, you then say, so A, the magnitude of A is 7.5 meters per second squared, vertically up, because this is positive. Okay. That's question 3. Question 4. I and J are east and north, so let's just put those on a diagram just to remind us. I and J, that's north, that's east. Let's just do that to remind me there. Okay, and the velocity vector is given by 16 minus t squared I plus 31 minus 8t j. Find the time at which the particle is travelling on a bearing of 45 degrees. So it wants to be travelling in this direction. So the 45 degrees, that's actually a nice one, because 45 degrees means the I and J must be equal. If it was an angle, then we'd need to get tan involved, and it'd be a lot more complicated. But actually this just means that the I component equals the J component. Now at this stage there were a surprising number of errors just rearranging this. Okay, so we've got no I's and J's in this because we've set the I component equal to the J component. Let's take it over to the side where t squared is going to be positive. We get t squared minus 8t, and we get plus 15. Okay, so then we've got t minus 3, t minus 5, so t equals 3 or 5. Okay. Okay, and then we want the speed of this particle. Okay, so to get the speed, we're going to need to shove it back into the velocity. So when equals 3, v equals 16 minus 3 squared I plus 31 minus 8 times 3 j. So this should give us the same thing. So we get 7I 24 plus 7j. Okay, so that's looking good. And we want the speed of that, so we want the magnitude of velocity, which equals the square root of 7 squared plus 7 squared is 9.9 meters per second, two significant figures. Okay, so what about when t equals 5, v equals 16 minus 5 squared I plus 31 minus 8 times 5 j, which equals 25, which is minus 16 minus 16 minus 9, and 31 minus 40 is minus 9j. So again, it's got the same components, but it's going minus 99 minus 9j. So this is not a bearing of 45 degrees. Okay, and that's quite sneaky. We've just got to be aware of that. But they do want you to justify why you've left out the t equals 5. Okay, question 5. So, on this one, let's just draw the diagram again. So we've got, just to go through it, we're getting more complex, so it just helps me to see what's going on. 2 blocks show masses of 4 kilograms and 6 kilograms on a smooth, connected by a light, inextensible string. So there will be a force that way and a force that way. We'll call it tension. And there's a 30 Newton force this way. And there's a force this way. Okay, and then we're going to say the magnitude of the acceleration of the system is 2 meters per second. Find the 2 possible values of f. Okay, so the magnitude is not telling you which direction. So I'm going to assume a, if this is my positive direction, a equals plus 2. So we've then got, in the positive direction, we've got 30. Considering f equals ma on all of it, we've got 30 minus f. So these have got forces on, but they're vertical and horizontal, so we're not going to worry about that. 30 minus f, positive direction equals mass, 10 times acceleration 2. So we've got, in that case, f equals 30 minus 20, which is 10 newtons. Okay, but we could also assume that a is minus 2. So then, in our positive direction, we still have 30 minus f, but now we have equals 10 times minus 2, which means we've got, take f over the other side, we've got f equals 50 newtons. And then we've got the tension in the string in each case. So part 2 is the tension. Well, now we're going to consider F equals MA on the 6 kilogram. I'm going to do it on the 6 kilogram just in case I've made a mistake with my first ones. So when A equals plus 2, I've got 30 minus T equals 6 times 2. So I've got T equals 30, 12, so T is 18 newtons. Then we've got the case, let's just do it over here, when A is minus 2, we've got 30 minus T, 6 times minus 2, so again we've got T is 30 plus 12, so T equals equals 42 newtons. And there are my two cases. Okay, we're on question 6. The particle moves along a straight line. Initially the particle is at O, so there's my straight line. O. Displacement is x, and its velocity is v, is given by, so v is 24 minus 18t plus 3t squared. Find the times t1 and t2, where t2 is greater than t1, where the particle is stationary. So 0 equals 24 minus 18t plus 3t squared, divided all by 3. Let's hope they've done it nicely for us. 8 minus 6t plus t squared, t minus 4, t minus 2, so t equals 4 and 2. T2 is bigger, so t2 equals 4 and t1 equals 2. Okay, there we have part 1. Find the expression for x at time t. So x, initially the particle is at O, so initially the displacement is 0, so x equals the integral of 24 minus 18t plus 3t squared between 0t. So we've got 24t minus 18t squared over 2 plus 3t cubed over 3 plus c. C equals 0 as x equals 0 when t equals 0. So when t equals 2, x equals 24 times 2 minus, we could probably simplify this, so 9 times 2 squared plus 2 cubed equals 48 minus 36, that's 12, plus 8 is 20 meters. And when t equals 4, x equals 24 times 4, that's 9 times 4 squared plus 4 cubed. I need to get my calculator out for this one. 24 times 4 minus 9 times 16 plus 64 is 16 meters. Okay, on to question 7 and section B. So we've got Abby pulling down on the rope there. So we've got 250 down, we've got 25 newtons across, and we've got a tension here. And we've got a force that's being pulled down. Okay, And so that's my angle theta. Okay, represent these as a fully labelled triangle of forces. Forces acting on the object, so acting on this object here. So I can do the one at an angle first of all. I've got that, I must have the arrow. That's my tension. G equals my F. That's my 25. So I could probably change these for Fs. There we go, 25 and 250 newtons. There, and the key is that they all meet up because it's in equilibrium. Okay, so part 2. Find F and theta. So we know that tan theta equals opposites 25 over 250. So theta equals tan to the minus 1 tenth, which equals 5.71 degrees. And we know that F equals the Pythagoras of that, so plus 250 squared square root squared plus okay. Now the distance one, it's easy to forget that it asks that, but we know that that distance is 30. This angle is still the same angle, so that's theta, and they want the distance between the object and the vertical, so they want this. So x equals, well, x over 30 equals tan theta. So x equals 30 times tan theta. Well, we know tan theta is 0.1, so 30 times 0.1, that means we've used the exact value, is 3 meters exactly. Okay. Okay, Abby then pulls the rope harder and the object moves upwards. Bob adjusts the tension in rope B so that the object moves along a vertical line. The situation when the object is partway up, the tension in the rope is S newtons, the tension in the rope is rope B is there. So give equations for equilibrium in the vertical and horizontal direction. So we'll just draw the diagram. There we go. So we've got S is an angle of alpha. Oh, that's not very vertical, but we get the idea. And we've got beta there, T, and we've got 250. Okay, so vertically, if we treat this as positive and this as positive, so we've got S cos alpha minus 250 minus T cos beta equals 0. And horizontally, we've got S sine alpha minus S sine alpha plus T sine beta equals 0. I just checked that the cos and the sine, I've got one cos and one sine and one cos and one sine. Yep, all good. So Find S and T when alpha is 8.5 and beta is 35 degrees. So from this equation, I've got T equals S sine alpha sine beta, and I'm tempted to leave it all in because these aren't going to be nice numbers. So then into my top equation I get S cos alpha minus 250 minus T, which is S sine beta cos beta. Bizarrely, that cos beta was missed by quite a few people. Cos beta. So we've got S brackets cos alpha minus sine alpha cos beta sine beta equals 250. So S is 250 over all of this. Cos alpha minus sine cos beta beta. Okay, and that's not very nice, but if I plug that all in at this stage, I'm not going to lose any rounding errors. So I've got cos 8.5 minus sine 8.5 times cos 35 sine 5, and that is 321.4 newtons. And T is going to be that number, keep in my calculator, times sine over sine beta. So times sine 8.5 divided by sine 35 is 82.8 newtons. There we go. And then part 5. Part 5 says, Abby's mass is 40 kilograms. Explain why it is not possible for her to raise the object to a position in which alpha is 60 degrees. So, let's just draw this diagram again. So, if that's 60 degrees, that's S. That's 250. That's beta. That's T. So the maximum force Abby can give is her weight, as she's not attached to the ground, which equals 40 times 9.8, which is 392 newtons. if that's 392 newtons, then if we consider F equals MA vertically, we've got S, which is 392 cos 60 minus 250 minus T cos beta equals 0. So 392 cos 60 minus 54. So we've got T cos beta minus 54. Well, cos is going to be positive for the angles, so T T would have to be pulling up. Which is not possible. So Abby would be lifted off the ground. That's not the only way of thinking about it, but I hope that makes sense. Okay. Okay, final question. 8. So on horizontal ground, sledge of mass 40 kilograms, pulled with 120 newtons force, constant resistance to motion, so we're going to call that my friction force. Tension in the rope is 120 newtons. The sledge is initially at rest. After 10 seconds its speed is 5 meters per second. So initially at rest, it's 5. Don't know its distance travelled, but we do know its time is 10 seconds. We're trying to find out the acceleration, so we can do F equals MA. V equals U plus AT, so A equals V minus U over T, which is 0.5. So then, considering this is my positive direction, F equals MA, so the force is 120 minus my friction force equals my mass times my acceleration. So my F equals 120 minus 20, so F equals 100 newtons, so my resistance to motion is 100 newtons. Okay, that's part 1. Part 2. When the sledge is at 5 meters, the rope breaks. So, new scenario. The rope's now broken, but the resistance to motion remains 100 newtons. So that's now the only force on it. We're going to keep this in my positive direction. New suvat, but where we've now got a new acceleration. So we can now work out the acceleration. So the force is 100 force in a minus direction equals the mass times times the acceleration. So the acceleration is minus 2.5. So it then says we want the speed 1.6 after the road brakes and 6 seconds after the road brakes. So S equals, we don't want S, U equals 5, V we're after, A is minus 2.5, and T we're given, let's start with 1.6. So V equals U plus 2.5 times 1.6 equals 5 minus 2.5 is 1 meter per second, so it's slowing down. When T equals 6. So when T equals 6, we do the same thing, and we get the velocity equals 5 plus minus 2.5 times 6 equals, I can probably do that in my head, minus 10 meters per second. And then you go, that is a resistance force that is causing that. So the velocity, therefore, velocity equals 0, because there is no way that the resistance force can actually make it accelerate in a negative direction. Okay, so that was the little thing you had to think about there. So that was B, and this was part A. Okay, so we're on to question 3, part 3 here. Okay, the sledge is now pushed to the bottom of a ski slope. The plane, this is a plane, is angular 15 degrees to the horizontal. The sledge is attached to a light rope which is winched to the top of the slope. The slope is parallel and has a constant tension of 200 newtons. The ski slope is smooth. Okay, so there is now no resistance to motion. Okay, so let's draw a new diagram. So it's 40 kilograms, so we've got 40 G here. So we've got 40 G, that's 15, so cos 15, and we've got 40 G sine 15, got our action here, we've got 200 newtons here. Okay, show that when the sledge has moved from being at rest at the bottom of the slope to the point where it's at speed, it has travelled a distance. So we need to get acceleration. So let's consider this as my positive direction. So 200 minus 40g sine 15 equals the mass, which is 40 times the acceleration. So we can work out from that the acceleration equals 200 minus 40 sine 15 divided by 40 divided by 40 is 2.465. 7. Let's keep that in. And then we've got another Suvat question. It seems lots of repeating. So we're now, we've got the acceleration. We know that it started at rest. We know that it ended at 8. We want to find the distance. not interested in time, so v squared equals u squared plus 2as. So s is 64 over 2 times my 2.46. So 64 divided by 2 times. Answer is 12.989, which is 13.0 to 3 significant figures. Okay, then we've got a very unfortunate incident again. When the speed is at 8 meters a second, this rope also breaks. Okay, so we've now got on the slope, we've got the object. It's travelled 13.0 meters, and the sledge find the time between it reaching the bottom. So we know the distance. It's going back the 13 meters. We know that it's got 40g here, so that's the 15. So that's 40g cos 15. So this is 40g sine 15. It's smooth, so that's the only force on it. So again, F equals ma. So the force is 40g sine 15 equals the mass, which is 40, times the acceleration. So the acceleration is 9.8 times sine 15. New acceleration, 2.536 down slope. Okay. Okay, and we know that it is going up so with our suvat, we know that the distance is 13.0 meters. We know that the u is 8 up, but the distance is 13 down. We know when we're not interested in the final v, we know the acceleration is minus 2.536. These are all important things, and we're trying to find the time. So we want the equation without v. So we've got s equals ut plus half at squared. So we've got minus 13 equals 8t minus a half 2.536 t squared. So let's take it all over so we get positive t squareds. And divide that by 2. We get 1.268 t squared minus 8t minus 13 equals 0. So t from the quadratic formula is minus b, so that's 8, plus the square root b squared, 64, minus 4 times 1.268 a c minus 13. Right, all divided by 2 times t equals 7.649. And if I put the minus in there, then we get a negative answer. So that's our answer, t equals negative answer. 1.65 to 3 significant seconds to 3 significant figures. And there we have it.